ENAC was the world's first fully electronic computer, and it was put together by some of the greatest minds in history, John Macaulay and one of my favorite mathematicians, John von Neumann. Now, this old computer used to take up an entire room, and it took great minds to program. But today, we no longer need computers the size of a room. We can do the same computations on something as small as this. I'm Zachary Anderson, and today we're going to be learning about microcontrollers. So, what is a microcontroller? Well, maybe a good analogy is to start with a computer. So on your computer, you can run a variety of programs. You can have a YouTube video playing while you're playing some sort of video game, and maybe you've also got, Word open because you're working on a homework assignment. Hopefully you're not multitasking like this. But these are all processes that require some computations, and each one is a separate task. A microcontroller is like a dumbed down computer that's able to perform a single one of these tasks, and maybe not at the same performance level, but at a simple enough level. And so they're great for applications in logging, moving actuators, and more. Now, microcontrollers are not just a full PCB like this. So when I say PCB, you can see that this is a fairly large chip, and there's some prongs at the end and a socket here. So the microcontroller is this little black chip right here. So this is the actual, basically, computer that's performing a list of actions in a sequence, right? So we can program these microcontrollers to do a variety of things. Now, they're great for performing, if you want to do some mathematical computations, that's okay. But they're better used for purposes where you want to automate things at a distance and probably using some sort of sensor, right? If we wanted to just solve some sort of math problem, we could probably just use our computers. It would do a better job and be a lot faster. But if you want to log data, or you want to, say, control the blinds in your room for some smart home automation, a microcontroller is probably the way to go. It's cheap, it's simple, and it's really good at doing that one single task. So what I'm going to show you guys next is how we can actually control this little microchip to perform a couple different tasks. So next, let's take our phalanges to the keyboard and do some programming. So you can take a look here. We're going to be writing some code for this microcontroller. So I'm going to start with pin mode, and we're going to select our digital pin, and we plugged our LED into pin 2, as you guys saw. We want to set that to be an output. Next, what we're going to do is we're going to type digital write, and we're going to set pin 2 to be high, and then we're going to delay 100 milliseconds, and then digital write, pin 2 low, and then delay again 100 milliseconds. Okay, and we can go ahead, we can save that, and then in our tools here, we want to make sure that we've set everything up correctly. So our board is an Arduino Nano. The processor is an ATmega 328P old bootloader, so there's different bootloader types. And the port that we're connected to is COM port 8. So that all looks to be correct. So why don't we go ahead? So we're gonna see what happens when I click upload now. So are you guys ready? Here we go, let's do it. So I'm clicking upload. Oh, and again, I make this mistake. Oh my gosh. Don't forget semicolons at the end of all your statements. Arduino is actually written in C++, and so we have to meet that same syntax. So let's go ahead, let's click upload one more time. There we go. So we're probably going to see a couple of flashing lights on the board that shows that it's programming, and now you should have a blinking LED, which is pretty cool, right? So we got our blinking LED. This is awesome. That's always what I ask people when they're working on a project. What's your blinking LED? Blinking LED means you can go home, right? Yeah, so we got our LED to blink, that's great. Now we know about microcontrollers. We know that they're sort of like a computer, that they can do a single task. And we learned how to actually program our microcontroller to just make an LED blink. And this is an example of what microcontrollers are really good for. Microcontrollers are really good for automating these simple tasks. If you wanted to log data or say run some sort of simple automation. Thank you guys for checking out this Make segment. Remember to check out our ZenMaker Academy online, particularly the electronics course. In that program, you actually get to use some of the same microcontrollers in your projects. And so it's a lot of fun, and I really, really enjoy it. I hope to see you guys next time. I'm Zach.